Hello. The following presentation will look at how designers can improve their product performance and reliability by asking the right questions of their products. As designers, we ask questions of our products all the time, but most of us use either our experience or gut feel to arrive at our answers. Today's designer has many tools at his disposal to ask the right questions. Today we are going to look at how we can use CAU tools to simulate the system or component performance, its manufacturing process or working environments, all of which will have an impact on the end user's experience of our products. So why would I suggest to you that you should be asking the right questions? By asking the right questions, you get information to reduce the risk associated with any design decision. Design is a process, it is a journey. As we're going through this process, we are continually making design decisions. How thick should this plastic part be? What gauge of material should we use? Do we use steel, aluminium, or another material? Asking the right questions is all about getting information, and information is key to getting better products. So what might be the right question to ask of any product? An obvious question to ask is possibly, why do people buy this product? The secondary question to this is very important. And again, if you can decide why people buy your product, can you then quantify this desirable quantity? Okay, can you measure it? Can you improve it? Because obviously if you can improve it, it then makes your product more desirable to the paying public and you're going to sell more product. So we have decided we're going to ask questions of our product. When do we ask these questions? We want to ask these questions, carry out these simulations as early as possible in the design process. We can change things without too much impact on everyone else. It's much better to find out after a week that your proposed design won't work rather than waiting 6 months. The best simulation model is the simplest one, which gives you the necessary design information. Don't wait for the design to be finalized. Early is better when asking questions. So, how do we go about finding the right questions? You find the questions by considering various aspects of its use and manufacturing. And it can depend not only upon how it's going to be used, but also how it will look. So things might be, how critical is the component fit? For a mobile phone, this might be very critical, but for some industrial frameworking, it might not be so critical. Will the manufacturing process lock in loads? The items have to be transported from the factory to the end user. How is that going to happen? Where will it be used? How will it be used? And what ways could it be abused? There are many other considerations you might think of depending upon the product. So let's look in a little bit more detail. First, we're going to consider the in-service loads and maybe the temperatures the product might see in its lifetime. Questions about how heavy it is could also impinge upon the loads it's seeing. Does it get hot during running? How much load does it have to withstand? Are the loads constant or varying? This is a very important consideration because a varying load will obviously have an impact on its fatigue lifetime or indeed any dynamic effects you might want to consider. The residual stresses due to either overload during its service life or the manufacturing process are important considerations. And again, the transport loads. Depending upon the product, you should be able to create a finite list of the in-service loads and temperatures your product might see. The second consideration is very, very important because we really have to start to think about not only will the loads the product will see during its lifetime, but what environment will it see and what abuse might it see during its lifetime. So we might have to think, where is it going to be used? From the extreme of the Antarctica to the Sahara or the rainforest. Okay, is it going to be hot and dry Is it going to be moist and wet? Humidity? Cold? All these things will have an impact on how your product will be used and how it might be abused. Is it going to be carried in a special case or someone's pocket? What impacts might it see in its life? Could a house brick fall on it, or is it going to be a paperback book? And most importantly, who are you selling this to? Is it going to be used by a child or a careful adult? So we're going to take these considerations and apply it to a simple handheld device. The first thing we're going to consider are the key performance indicators for this product. Or put it another way, why do people buy this product? Is it the ease of use, the completeness of the features, the cost, its weight, the styling? Depending upon the product, this list can be never ending. But once we have this list, can we then turn these key performance indicators into quantifiable items that we want to measure and improve? We can then look at how the product might be used and where it might be used. Again, splitting it up into load considerations and environmental considerations. So once more, load can be heat and cold temperatures. For a handheld device, obviously drops and impacts are very important. Is it going to be used very carefully with only hand or finger loads? Or is somebody going to stand on it by mistake or sit on it? Other things with electronics might also be electromagnetic interference. Now moving on to the environmental considerations. In this I've actually included a manufacturing consideration. The multiple plastic parts have to fit together to make sure the styling is correct. But true environmental considerations might be, where is this going to be used? Does it have to be waterproof, water resistant? Dust in sandy locations, we want to make sure that the dust and sand doesn't get into the product. Is it going to be used for a long time at elevated temperatures? Typically, electronic components don't like that kind of behavior. So once we have these considerations, what we then want to do is convert them into simulations that our CAE tools can carry out. So we're going to convert the environmental working challenges into different types of simulation. So when we think about the multiple plastic parts coming together, we can consider fit, maybe do a tolerance analysis. One of the KPIs we might consider for a handheld device is the cost. A big impactor on the cost of the product is its material content. So maybe you want to do an optimization of the material. Now this optimization might be choosing material A over material B, or indeed it might be reducing the amount of material without sacrificing the strength of the product. So considering the actual use cases, heat and cold, obviously that can be done by thermal testing. Dropping on impacts, now these require some sort of dynamic testing. Waterproof and water resistant, simple pressure loads, pressure tests. The dust in sandy locations, again this is a little bit more complicated, but what we want to do here is do an in-use test of loading and abuse to make sure that during this process we have an adequate seal contact pressure throughout the entire working environment. So let's look at another case study. What we're going to do here is we're going to talk about a company called AP Racing. AP Racing live in the rarefied world of high performance automotive manufacturing. They are one of the world's most successful Formula One suppliers of brakes and clutches, but they also deal in other forms of motorsport and high performance cars. But it's not so much what they do that makes AP Racing such a good example. It's how they go about what they do. So again, we're going to look at just one of their products, the brake caliper. So the first thing they do is they consider what makes a good brake caliper. They want to identify the key performance indicators. Now, two of these key performance indicators can be measured by simulation. Basically what they want to do is they want to measure the stiffness of the caliper against its weight. Okay, the stiffer it is, the better it is at braking, but they also want to make sure that the material maximum stress doesn't go too high, resulting in failure. So once they've got these KPIs, they will use the environmental information and working loads to decide what type of simulations they have to carry out. So here's a graph from one of their design cycles. On the upper right, we have the performance curve of their existing design, of its stiffness against weight. On the bottom left, we have the design goal. This is very important. Not only have they actually quantified what they want to measure and what they want to improve, but very sensibly they have decided in advance at what point will they stop the design process and actually manufacture something. So when we look at the brake caliper, we can see there are different ways to actually reach this design goal. Firstly, we can just reduce the weight and keep it at equal stiffness. We could keep the weight the same and increase its stiffness. But best of all, we want to reduce the weight and increase the stiffness. Now the pink dots on there are the points in which they carried out these design processes. As you can see here, it's not a linear process. Many design iterations went through before they reached their design goal. If you think about it, there's just no way you can actually physically prototype this number of tests. In summary, when we think about asking the right questions of our products, the first step is to identify and measure your product's critical KPIs. With this identification and measurement in place, you now have a purpose for your simulations. Remember to include manufacturing, usage and environmental effects in your simulations. By asking questions early on in the design phase, you will reap the greatest benefits. But remember, it is very important to set a clear and defined goal of your simulation. How much do you want to improve your critical KPIs? I hope you'll agree with me. Simulation isn't rocket science. It just takes a little bit of preparation. Thank you very much for your time. I hope you found this instructive. If you have any other questions, do not hesitate to contact your local reseller or visit the SOLIDWORKS website, or indeed contact me at the email shown here, and I will endeavour to do my best to answer your questions. Once again, thank you very much for your time.